Okay, this is help on number 8 from chapter 13.4. So all I want to do is load up the data into StatCrunch and do a two-way analyzation of variance. And I want to make sure that I compute the Tukey, or complete the Tukey test on them. Oh, sorry. I forgot to, my responses are in compound. My row factor is going to be the gender, right? And my column factor is going to be the ages. Okay. So then I just hit compute. And the question I received from a student is, how do I get the test statistic and the p-value? So the first thing we want to do is, is there an interaction between gender and age, between the two factors? And so we go up here to this analyzation of variance table, and we check the interaction row, and we can get the f-stat, right, which is really the test statistic. You can see that lines up with the right answer, and the p-value here, okay, from the interaction. And then it asks, going down, determine whether there's a difference in the means for the genders. Okay, sorry. I don't think I read that right. There is no significant interaction, which we determined there wasn't, right? The reason was the p-value was high, right? It was above the 5% significance. And if there's no significant interaction, determine whether there's a significant difference between the means of the three age groups. So for here, we go to the age factor, and we get the f-stat and the p-value, right? Which are going to be right here and here. Okay. And then we'll have to do the same thing. They're going to ask us to do the gender, see if there's any significant difference between the gender here and here. And since the p-value is high, there's no significant difference. And then it wants us to go all the way down here and see if there's a significant difference in the means for the three age groups. And that we have to use the Tukey test for. That's why we selected that little thing. And we look down here. This is the part you want, where you have the ages compared. And so if you take the age group 18 to 34 and subtract it from 35 to 54, you see you get a low p-value, which means that those means, remember for the hypothesis test, the null hypothesis is that they're the same, right? They're equal, and the alternative hypothesis that they're not. So that low p-value means that 18 to 34 is not the same as this. Also, because this p-value is low, it's not the same as the 55 and older, okay? Now, if 35 to 54 is subtracted from 55 and older, that p-value is high, so those aren't significantly different means, okay? So the one that's kind of significantly different from the other two is the 18 to 34, and that's why it's selected here. So I hope that helped a little bit on that question. That was a long question, and I went through it really quickly, so, don't be afraid to ask questions.